Investigation into near counter stresses in stopping with backfilling by the polarization-optical method. When performing stopping operations, there is a tendency of increasing the roped-out space in rooms, resulting in changes in the volumetric stress state of the rock massif adjacent to the stopping area. That consequently initiates geomechanical process that causes strains of the rock massif and stope counterclaps. The nature of geomechanical process occurring in the rock massif adjacent to the roped-out space is determined by mining and geological conditions. With increased mining depths, rock pressure naturally increases, and so do stresses in the near counter massif in room and pillar mining. In conditions of mining deep levels of the Belzirsky deposit, poor stability and low strength of the hanging wall rocks are the main and determining factors causing disturbance of stopping area contours in mining operations. Low and extremely low stability of ores and country rocks contributes to lost stability of stopping area contours. The research aims to develop recommendations on parameters, forms, and procedures for stopping, including search for possible partial changes in the shape of stopes and procedures of their mining under increased stresses in the near counter massif when conducting stopping operations by the room and pillar method with backfilling. To research into stress in the near counter massif when stopping, a polarization-optical method with transparent models made of optically sensitive materials is used to obtain data on distribution and values of stress in the rock massif with mine workings of various purposes and sizes. The polarization-optical methods of studying stresses is based on properties of most transparent isotropic materials to acquire the ability of double radiation under the influence of stresses. The value of double reflection associated with that of stress can be measured optically when the model is transilluminated with polarized light. Polarization and double reflection are optical phenomena underlying the polarization-optical method. The method of photoelasticity is based on laws of the elasticity theory, which state the relationship between stresses and strains is subject to Hooke's law for triaxial stress is expressed in the form of. To solve a flat problem, Hooke's law is written in the form. The polarization-optical methods of studying stresses on transparent models of optically sensitive materials makes it possible to obtain distribution and values of stresses in the rock massif with different geometric parameters of the stope. To study the stress state of the rock massif on polarization-optical models, the latter are made of low modulus materials that operate under their own weight. The optically sensitive material Igdantine, the Igdantine model is made according to the generally accepted methods. Making the model stopping is modeled according to the scheme in figure 1. For stopping continuous of partial undermining of the hanging wall rocks in the plane of contact with country rocks of hanging wall as shown in figure 2. For breaking stope reserves so that in the place of the roped out stopping area, exit is in contact with the hanging wall rocks, an arched form of the roped out area is formed. During the test, isoclinic images and isochromatic images are photographed at different angles of the polarizer. The performed researchers of the manufactured and tested models made of optically sensitive material during transillumination by polarized rays allow obtaining data on distribution and values of stresses in the rock massive adjacent to the mined out stop. The research is performed in accordance with generally accepted classical methods. The testing results of models are processed after testing each model. Based on the calculation results, there are curves of stress concentration factors built for each model in the area of stop influence as they move away from the contours of the roped out stopping area toward the hanging and footwalls. The research indicates that stopping in the hanging wall of the deposit with partial undermining of the hanging wall rocks in the plane of contact with country rocks of the hanging wall stresses reach from 1.8. At the transition point of the inclined exposure of the hanging wall rocks into the vertical stop wall from the hanging wall side to 1.9 at the transition of the inclined plane of the exposed country rocks of the hanging wall in the stop crown. With an arched form of the roped out stopping area in contact with the hanging wall rocks in the middle of the arched crown, stresses reach 1.1, which is much less than partial undermining of the hanging wall rocks in the plane of contact with the country rocks of the hanging wall, with stresses reaching from 1.8 to 1.9. Thus, the results of the research enable stating that with hanging wall rocks of medium and low stability, it's expedient to form an arched stop in contact with the exposure of hanging wall rock in order to prevent collapses of the hanging wall rocks into the roped out stopping area, which can cause greater of delusion.